I'm recording. Let's look at attendance here. Bryant is here. Curry is online. Darby is online. Fisher is not here. Hamilton is online. Hellman is here. Ashley is here in red. Both of the Millers are here. Norris is here. Rollins is online. Shamblin is online. And I think that's it. Check one more thing. Rollins, Darby, Hamilton. Yep, that's it. It's 8 o'clock. Go slow. Hope one more person shows up. It's at least one more person that's usually here that's not here. Anyway, so some of you may have heard from our discussion, the student evaluations were not in my mailbox today, so we are not doing student evaluations today. So hopefully somehow we might be able to figure out how to do it online, because online courses, like the 100% online courses, they do have online evaluations. So I'm hoping since we are 30% online, I can get my people to make an online evaluation for you guys, and you can fill it out. Be very helpful. I love the feedback, the good and the bad. Like she was saying, technically, some people need it for promotion and stuff like that, but I'm not eligible for promotion. So I don't care about it for that reason. I just want feedback so I can make these courses better for the students that come after you. So that'd be greatly appreciative if you did that, when and if I can make it happen. All right. Anyway, let's jump back into chapter 20. Today should be a quick day because there's not much left of chapter 20, and after chapter 20, we're done. Like I said, I'll remind you, you should read the chapter 21 in your textbook, but all the important information that you're going to be tested on, chapter 21 in your textbook, is in this PowerPoint, the chapter 20 PowerPoint. Anyway, we finished, we were talking about movement corridors. Here's a picture of a man-made movement corridors. You may have seen these online. I've seen them a few times on social media. It's basically just a bridge, but instead of, well, in this case, it's just a bridge, but instead of a road being up there, that's just a patch of wildlife, right? Some soil, some grass, a few plants, a few trees. But anyway, oh yeah, sorry, here's some more pictures. This is more of a natural, right? So you can see this probably all used to be forest, but we cut the forest down and used it for agriculture. But whoever was in charge of that did leave some movement corridors. Of course, they're probably used for other things other than movement corridors, but nonetheless, those movement corridors are here. And again, like I said, I guess I should do attendance words first. Sorry about that. First attendance word will be, oh no, farm. It's like a farm right there. So farm is the first attendance word. I just stick with what we've been doing. If you're watching this video at a later date, send me a picture of a farm, not that one. But anyway, like I was saying on Wednesday about things being common sense, right? You might just see, like, assume these movement corridors weren't here. You might just see a big open field and think, yeah, that's no problem. If a bird needs to get from here to there, it'll just fly across it. And probably very often that is the case. But very often, unlike what might go against common sense, some animals, they do need this movement corridor. Some animals just won't fly across an open field. It's actually pretty smart when you think about predators like hawks and falcons and things like that. But anyway, again, my point being that this whole idea of conservation and ecology, it's not always common sense, right? This is why we have to have people who study it. Speaking of which, let's talk about restoring ecosystems. So what we left off with was talking about how to better plan, like when we were expanding the human population, how to plan properly, how to plan our farms, like we saw in that last picture, how to plan our cities. But now we're talking about how to fix the stuff we've already messed up, as opposed to planning ahead. And that brings us to one word you might need to know, which is bioremediation. And I put a question mark because I don't know if I'm going to ask you about that or not. What is bioremediation? It is when we use living organisms to detoxify polluted ecosystems. So for example, we have a scientist in Hamlin Hall here who works, he's a soil scientist, and he actually works with different plants that are good for removing heavy metals from soils and mine sites, which is good for here, right? Because we have a lot of mining down south. So what he's working on actually has an impact for West Virginians. Anyway, here's some examples from your book. Not that you need to know any of these, but there's bacteria that's been used to clean up old mining sites and oil spills. Speaking of which, they're working on new stuff now. There's bacteria that they found that actually eat plastic. which is not mentioned up here, but yeah, that's a new thing. They use plants to remove toxic substances such as heavy metals and organic pollutants from contaminated soil. So this one right here is the example I was giving about the scientist at Hamlin Hall. But anyway, again, for the exam, if anything, you just need to know about bioremediation, right? It's using living things to clean up a mess that humans made, basically. Any questions about that? All right, here's a picture of a researcher from the U.S. Department of Agriculture who's investigating the use of canola plants to reduce toxic levels of selenium in contaminated soil. So again, it's very much like what's going on here in Hamlet with one of our scientists, looking at different plants, and not just different species, like is this species better than this species, but also different breeds of the same species, or even genetically modifying certain species so that they're better equipped to do that job. This example is not from your book. Actually, I need to read your book. This example is definitely from your old textbook, but I can't say for sure off the top of my head that this is in your new textbook. Anyway, as usual, it's just an example, so I'm not going to ask you questions about it. But some projects have a broader goal of returning ecosystems to their natural state, right? So again, what we're talking about now, that main bullet point that we're talking about is not planning ahead, right? Because that's what we talked about on Wednesday, was like how to develop the expanding human population. Now we're talking about how to fix our problems. And the last thing we talked about, bioremediation, was like, yeah, it's fixing a problem. It's fixing like the oil spill that we made, but it's not completely fixing it. And what we're talking about now is like really turning things back to the way they used to be. Anyway, there's this river, it's called the Kissimmee River. It's in Florida. It used to be a very shallow, meandering river that was between two lakes, but we straightened it out for human use, right? So about 60 years ago, we straightened it out. We dredged it, right? So made it deeper. We drained about 31,000 acres of wetlands. And as you can imagine, doing all this had a very significant negative impact on the fish and the wetland bird population. So what they did, this restoration project, and again, I'm gonna put it next to this, indicating I'm not gonna ask you any questions about this example. They removed water control structures, so dams, dikes, reservoirs, things like that, anything that's holding water back or, artificially putting it somewhere that it didn't normally want to go. They removed it. They filled in about 35 kilometers of the canal, and the first phase was completed in 2004. I haven't gone back to see how much they've done so far, which stinks because I'm from Florida, is one of my home states, and I should be on top of this, but I'm not. Anyway, after that first phase was completed in 2004, wildlife returned in unexpected numbers, and the marshes filled with native vegetation, and game fishes came back to the river. So here's a picture of what we're talking about. There's the Kissimmee River. Again, like I said, it's between two different lakes in Florida, Lake Kissimmee, Lake Okeechobee. And you can see this is what it looks like, but this is where the canal used to be. And again, this might go against common sense, because common sense, you might just imagine if you saw this picture prior to this, right? So you only saw the canal. You might just look at it and say, yeah, that looks fine. I see a straight river. I see green. I see plants. So it looks natural to me, right? So again, it takes people who know these things, it needs people like ecologists to understand that, it's not always common sense. Looking at something doesn't tell you anything. Well, sometimes it does, but not in this case. Anyway, any questions about that? This is going to be a really quick day. The last main bullet point right here is the goal of sustainable development. So as the world population grows and becomes more affluent, as in richer, right, as we have more resources and money, the demands for our ecosystem services, such as food and water and wood and all the other stuff the ecosystems provide us, it also goes up, right? So you already learned this previously. Basically what this bullet point is saying is the more affluent a country gets, or a family or a person, the more resources they use, right? We all know that, and these are just some examples. Obviously, when you memorize those three, your book just chose those three as an example. But think about any ecosystem services, right? We don't have time to get into it. That's basically the beginning of Bio 108, if you're interested in taking that. But anyway, the goal of sustainable development is to meet the needs of today without limiting the ability of future generations to meet their needs. And that's a big one. That's really what sustainability is. And again, if you take 108, that's basically what the whole thing's about. It's all about sustainability. And sustainability is about being able to take care of yourself, right? Meeting the needs of today, but also being able to meet the needs of tomorrow. So for example, we talked about that fishery that collapsed. I think it was the last chapter. And that's a great example of not being sustainable, right? Sure, they took care of the needs of today because they caught all the fish they needed. But in that case, they accidentally caught too many and the fishery collapsed. Therefore, it wasn't sustainable because they were not able to meet the needs of tomorrow. So yeah, the goal here is sustainability. And like I keep saying, it literally is a matter of life and death. And I'm not one of those people who's trying to scare you and say, if you don't vote this way, then the whole world's going to end in 4 years, right? I'm not putting a timeline on it, as some people do. I'm just saying, eventually, this is all a matter of life and death, right? We have to be sustainable. Otherwise, we're going to run out of resources, right? Places to put our trash, food to eat, oxygen from photosynthetic organisms, so on and so forth. So sustainable development depends on continued research. I keep beating this dead horse, right? I keep saying that a lot of this stuff is not common sense, right? Common sense tells you one thing, but then when you research it, it turns out that common sense may have steered you wrong. Also, like we learned about using that fish collapse as an example. Remember that happened because somebody made a mistake. Remember I'll try to draw it. Remember I was saying, this is one of those things you need to know for the exam. That's the population growth, right? There's carrying capacity right here. That's the logistic population growth. These are all good pressures for things you need to know. And here we are about halfway between the population of 0 and the carrying capacity. And that's what they were shooting for, right? When you're talking about sustainability, harvesting fish, for example, you want to get right there in between because that's when you're catching the most fish, but also the population can handle it. So that's the number you're shooting for. But they made mistakes because their research was flawed, right? Whoever was in charge messed it up. They had the wrong numbers, and therefore the fishery collapsed. So again, that's just one example of why this research is so important. And that's more important for you guys because none of you are biology majors, so you won't be doing any research. But one day you will be voting for people and that might be some things they argue. Like, look, the government's spending too much money. And then it's like, well, we need to quit spending so much money on this, and it might be some sort of continued research for sustainable development. So anyway, again, the idea here is for you to know these things so you can make educated decisions. Once you're an educated college graduate. Anyway, sustainable development also depends on the application of ecological knowledge. So obviously, we can't just do the research. We need to apply what we learn. That makes sense. And it also depends on the connection of life sciences. This is my favorite bullet point right here. The connection of life sciences with social sciences, economics, and humanities. And the reason I love that so much is one, because this is basically Bio 108, right? I don't think only one of you had it. But it brings in all this other stuff, social sciences, economics, humanities. And social sciences brings in a lot of stuff, right? When we're talking about social sciences, we're talking about political science and a bunch of other things. But anyway, point here is, and again, one of the reasons I love this is because even though you guys aren't biology majors, this is all important. Like, we need all people to help understand this stuff and vote this way and vote that way. Anyway, to make informed decisions, whichever way you vote, whichever decisions you make, at least hopefully they'll be educated decisions. Any questions about that slide? All right. Next word for attendance will be the one I circled right there. That's the next word for attendance. So if you're watching this video later, send me a picture of one of those things. Anyway, sustainable development aims to conserve biodiversity. Obviously, right? That makes sense because this is the only thing I've been talking about this whole time is basically the health of the ecosystem, which is biodiversity, but also to improve the human condition, right? So again, like I've been saying since we started this section, I keep using the word tree hugger, right? This isn't all a bunch of tree hugging stuff. That bullet point is, right, conserve biodiversity, sure. But it's also about improving the human condition because the human's condition relies on biodiversity, right? So these things aren't mutually exclusive. So public education, political commitment, and cooperation of nations are essential to success. And again, that's where you would come in, just being an informed college graduate. So you can make informed decisions when you vote, informed decisions when you sit on a jury. You make informed decisions as a consumer or as a patient, right? All those things. And the awareness of our ability to alter the biosphere and jeopardize the existence of other species as well as our own may help us choose a path towards a sustainable future. And that's it. We are done with Bio 101. Any questions? Awesome. All right. Well, I'll try to be on this week as much as possible. So if anybody needs my help studying for the final, which would be Monday at 8 a.m. in this room. So far, only one person has contacted me to schedule a time to take it some other time. So it's technically too late, but if you get in touch with me soon, then we can come up with another time to take it next week. To meet online and take it next week. That's it.